Okay, I've got the top of the hour on my clock, so we're going to get started. Welcome, everyone. Thank you for taking time to join us on this webinar about climate-resistant infrastructure for extreme weather events. So when extreme weather events occur, communities are often left to grapple with the devastating effects. An increase in extreme weather patterns, coupled with aging or inadequate infrastructure, amplifies the often dangerous and costly damage that ensues, especially for vulnerable communities in low-lying areas. So in this webinar, we're going to discuss how to incorporate the GeoWeb GeoCell product into projects to create climate-resistant infrastructure in load support, slope stabilization, channel protection, and retaining wall applications. The discussion is going to include solutions for an array of industries, including the energy industry, transportation, and stormwater management. We're also going to cover some project case studies that will show how this advanced geosynthetic technology can be used for rebuilding storm-ravaged roads, repairing and stabilizing channel embankments, and preventing flooding after extreme weather events. I'm your host, Sam Justice, and I am a licensed professional engineer in the state of Wisconsin with degrees in civil and geotechnical engineering. I'm one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Throughout our extensive national and international distribution network, we offer technical and site support, as well as free project evaluations from our in-house design engineering team, like me. So infrastructure development for highways and roadway corridors face many challenges when it comes to project design and construction. Building asphalt or concrete roadways over soft soils can require thick base layers of expensive stone, and pavement surfaces often fail after just a few years of installation. Expanding roadway widths requires steepening corridor embankments, leading to potential slope failures that can cause those road closures and damages. Stormwater management alongside roads is an increasingly common concern due to limited construction space and larger storm events due to climate change. Presto Geosystems offers a cost-effective and low-maintenance solution for all of these potential issues using our GeoWeb 3D soil stabilization system. So for this webinar, we're going to discuss how to utilize this type of solution to address these types of challenges in your aging infrastructure due to climate change. Quickly, a little bit of background about Presto Geosystems. So we worked with the U.S. Army Corps of Engineers to develop the GeoCell technology in the late 1970s and have been innovating in this market ever since. Our products have been used in over 200 countries and in every state in the United States. And we go beyond simply providing a product. We're going to help you provide a complete stabilization solution for your specific project. We do operate in three main product areas: soil stabilization using our GeoWeb GeoCells, which can be used for load support, slope and channel protection, and constructing green retaining walls. Then we also do porous pavements, which we have both vegetated and aggregate solutions, and lightweight reusable construction mats. Today, we're going to focus on that top line using the GeoWeb GeoCells. That's where we're going to have our focus today. So we're going to cover some general information about the GeoWeb system, about that type of technology, for those who may not be familiar with this type of product. It's been around for a number of years, like I said, but it is still new to a lot of people. So the GeoWeb system is our version of the GeoCell technology, and it consists of two main attributes. The first is going to be the cell or the container size. So the cells come in three diameters, a small, medium, and large opening, with cell heights of 3, 4, 6, 8, and 12 inches. These dimensions are going to depend on your project-specific details and if you have any specific vehicle loading requirements. And we can help you determine which one is going to be the most appropriate for a specific job. There is no one right answer. Also, we do offer 5 section lengths to best fit your project needs, to give you a little bit of flexibility to make sure that you have full coverage. So the ultrasonically welded seam is going to be where all of the connecting points are. And it's very important to the function of a GeoCell. The stronger the seam strength, the better the performance the GeoCell will have. A strong seam allows for heavier infill material, steeper and taller slopes, and better lifetime performance. The GeoWeb product is produced using a high-quality virgin, high-density polyethylene, HDPE resin, for consistently strong welds at cell junctions, while also maintaining semi-rigid ductile properties within the cell walls, high stress crack resistance, and overall toughness and long-term durability in any type of environment. Our GeoCells do not use fillers or exotic polymer alloy blends, anything fancy like that, because those can ultimately reduce that weld strength and your environmental stress crack resistance. And you don't want that. You want those things to be as optimal as possible. Things like fillers and polymer blends are offered in some competing products in the name of increasing cell wall stiffness, but you do want to avoid that because you don't want things like weld failures or differential settlement. You want to focus on having uniformity in your performance across all elements of a GeoCell system, which is going to be much more important than focusing on a single characteristic like stiffness alone. So I mentioned there were two main attributes. The second attribute of the GeoWeb system is actually going to be the infill material, so what you put into the container. An important benefit of the GeoWeb system is that even low-quality aggregates, sands, or even certain salvaged on-site materials can be used to infill the cells. Using an on-site aggregate or sand can save significant amount of money and material and hauling costs. And you can also do something like eliminating the fine content of your material when it's needed, since the cells provide the confinement and aid in compaction of those cohesionless materials. Without the fines, you can significantly improve the drainage through the system and let the water flow freely, preventing poor pressure buildup and potential global failure across the cross-section. The ability to use sands or other low-quality aggregates really sets the 3D GeoWeb system apart from things like planar geogrids and geotextiles. Those type of products require high-quality materials with really high friction angles to achieve their optimal performance. With the GeoWeb system, low friction angle materials are just fine. The GeoWeb panels will still achieve their full potential even when poor materials are used. So you can have some pretty big cost savings there as well. So we're also going to have some system components. These are going to be all of the supporting pieces that help the GeoWeb panels protect your roadway, your base layers, your slopes, retaining walls, that sort of thing. And they're also going to ensure a relatively uniform performance across the whole interconnected system, thereby protecting against things like non-uniform deformation and differential settlement in response to applied loads. Okay, so if we think back, I did mention those, you have the panels, and the thing that you want to do is have full coverage. You don't want to have any gaps in your project area that you aren't anticipating. So to do that, you are going to need to have a connecting device. And we use our Atra key. So it is going to be that first component in a completely integrated system, connecting each individual panel of the GeoWeb into a single web that covers your entire project site. It allows for faster installation of the GeoWeb panels and is going to last the lifetime of the project, ensuring that your roadway or slope is protected and that the GeoWeb system is not going to fail under anticipated loads. The specific engineering values of the Atra key are going to ensure that the system holds up to loading over time without the corrosion that you can see in metal staples or the failure of underperforming cable tie systems. And there is a specific Atra key called the Atra wall key for a completely integrated earth retention system. And so this is what we use to connect adjacent GeoWeb retaining wall sections through the material eye slot. So this is going to be specific to retaining wall applications, whereas the standard Atra key is going to be for your load support and slope and channel protection applications. The Atra wall key includes an integrated washer at the base of the handle for coverage and has frictional barbs for improved interlock with the GeoWeb sections. And it is formulated to withstand weathering and ultraviolet radiations, which basically means it can be exposed to the environment. It doesn't need to be buried or hidden. So it's not going to corrode or photodegrade, even when exposed to really harsh environments. And securing sections with the Atra wall key is going to be a lot faster than using metal staples or zip ties, requires no special tools, and can be completed by a single installer in one easy turn. So that's how to connect all of the individual panels. But if you need to go on your slope, if you have your channel with some side slopes, you're not necessarily going to have a flat geoweb, obviously on the slope. So you're going to need anchorage to hold it in place so that it doesn't just slide all the way down your slope and therefore not protect anything. Don't want that. So for shallow slopes, think 2-to-1 horizontal to vertical or less. A stake anchorage is usually going to be sufficient. We do have two options for stakes. One is made of your standard steel rebar, and the other is made of high-density polyethylene, that HDPE, same as the GeoWeb panels. That's what's shown here. So if you're in a saline environment, so if you're along a coastline, the HDPE speed stake is going to be a lifesaver compared to those corrosion-prone steel stakes. And the stakes can be driven either by hand or by power drill, which is what this guy is doing. Looks pretty fun, not gonna lie. So that's an option when you have relatively shallow slopes. But a lot of times you are gonna have steeper slopes. You can have slopes all the way up to a 1-to-1, so 45 degrees, sometimes even steeper than that. And also sometimes you are going to be over a surface that can't be punctured. So if you have a geomembrane liner down on the slope, you obviously aren't going to want to drive a stake through that. It's going to defeat the purpose of the liner. So in those cases, you're going to use a tendon anchored system. And we have our Atra tendon clip, which is a load transfer device to carry the load from the heavy infill materials that you would choose to the tendons and then up to a crest anchorage system. So only the Atra tendon clip is specifically designed to fully transfer safely and securely the forces placed on a geocell. Every accessory that we have has been designed and tested specifically to work together with the GeoWeb panels so that we can go from problem to design to construction solution with a system that really models and replicates real-world forces. And so in order for a geocell system to perform uniformly, which is kind of the key word that I want you to take away from all of this, it's critical to have both factory welded junctions, so those internal points, and then also field joined junctions that connect the individual panels, so the mechanical junctions. And those have to perform at a level that's commensurate with the cell walls. So it's three primary elements: the cell walls, the internal junctions, which are those ultrasonically welded seams we looked at, and then the connectors, those Atra keys, we talked about those as well, must perform uniformly as a complete system. Therefore, an incremental improvement in a single characteristic, such as cell wall stiffness, is only going to be valuable if a complementary improvement has been made in the other components within a system. So you can't just prioritize one over the other. The GeoWeb system is going to be manufactured with that high quality virgin HDPE. So our proprietary formula has stood the test of time for more than 40 years, and it's going to be more than adequate for pretty much all typical sites. Can have a durability of greater than 50 years, with lab testing indicating more than 150 years without degradation, even at full exposure to the elements. So we stand behind our numbers so that you can deliver certainty in a solution as you build with materials that you can trust. Additionally, for those who are in the United States, the GeoWeb and all of our products and accessories are 100% made in the USA. So if you are working on something like a federal project that has Buy America or Made in the USA requirements, all of our products do meet those standards. So just something to keep in mind. Okay, so now we're going to move on to discussing our soil stabilization capabilities with the GeoWeb system, specifically how they can relate to load support applications. So Presto Geosystems offers solutions for many different types of road and highway applications, load support for both unpaved roads, road shoulders, and base stabilization underneath paved surfaces. Plus, stormwater control is going to be possible when using the GeoWeb geocells through roadside ditches, drainage channels, and culvert outfalls. So the purpose of cellular confinement is very simple. It stabilizes the movement of unstable soils, both horizontally and vertically. The weaker your subgrade conditions, the more practical it becomes to insert the GeoWeb system into the design. It's an engineered system integrating multiple types of geosynthetics with the best method of confinement and subgrade stress reduction in the industry. And so although today's discussion is going to focus on the GeoWeb system sort of for roadway infrastructure, other load support applications include things like intermodal yards for heavy equipment and container storage, and things like rail ballast reinforcement for railways. So there are lots of applications that we're not specifically talking about today, but that we do cover. So the GeoWeb's 3D system works like this. When a vertical load is applied, the active earth pressures in the loaded cell pushes back against the passive earth pressures in the adjacent cells to form that stable system. Being confined, the soil responds passively. The infill is limited in its movements, represented by those yellow arrows in the center, and the cells adjacent to the loaded cell provide passive resistance. So there's going to be the red arrows pointing back in. The load is dispersed over a greater area in the lower layers as each cell helps supports the one around it. And then the GeoWeb cell walls also transfer hoop stress, which is going to be important in keeping the system intact and creates what we call the mattress effect. The strength of the seams around each cell, that's the ultrasonically welded seam we talked about back in the beginning, plus the material properties of the individual strips, so the HDPE resin, and the connection method, those ATRA keys, are all going to be important factors in determining how the GeoCell system can improve the load bearing capacity. Strong seams, semiductile resin properties, and integrated connections are all critical to a well-performing system. The GeoWeb system plus its accessories are specifically designed to work together to be an effective, permanent solution for roads in soft soil conditions. So in a load support scenario, vertical deformation can only occur when either compression or compaction of the soils or through lateral movement of the soil particles. By spreading out the load in the classical granular fill approach, one can reduce the compaction of near surface soils, but only with the cellular confinement of the GeoWeb panels can you assure that there's no lateral shifting leading to ruts. So this mattress effect reduces the stress reaching your subgrade. And here you can see that. So the stress is on the subgrade with the unsupported subgrade on the left, and then with the GeoWeb reinforced system on the right. Notice how there's a complete elimination of the highest stresses at the surface with the GeoWeb reinforcement. The stresses are reduced and distributed over a wider area. And this mattress effect reduces the stress reaching the subgrade and leads to a significant decrease in deflection and rutting. And by eliminating that lateral particle movement, because the infill material is confined within the containers, those cells of the GeoWeb panels, the GeoWeb system can stabilize the surface, reducing or even potentially eliminating the need for constant surface maintenance. And so here you can see a pretty impressive load support benefit using an 80,000-pound loaded dump truck. So this is going to be, in the US, your standard AASHTO H20 loading parameters. So this is on a partially filled GeoWeb panel over a soft subgrade. And you can see how the cells push back against each other to support the load, and that only the adjacent cell needs to be filled for a single cell to provide support. So a great benefit to using the GeoWeb system is that you don't actually have to have every single cell completely filled in before the road becomes usable. You can reduce your construction time and materials with this approach, all with about half the cross-section required by traditional methods to support the same load. And the GeoWeb system is often compared to 2D geotextiles or geogrids, and they do kind of start with the same concept. However, due to the 3D nature of the GeoWeb system, it's got that defined depth. The integrated infill geosynthetic system acts as a composite layer where lateral earth pressures are mobilized and transferred across the three-dimensional network of interconnected cells. So again, mattress effect. Because of this phenomenon, lower quality fill materials, things like sand or salvaged material from your site, can be beneficially reused, eliminating the need to import expensive aggregates as required with things like geogrids. The GeoWeb system uses a thinner cross-section as well. Typically, a 6-inch GeoWeb system is going to be equivalent to a 12-inch GeoGrid system. which can require 2 or more layers of geogrids depending on how soft the native soil is. And we can also eliminate fines when desired, since the cells provide confinement and aid in compaction of those cohesionless materials. Without fines, you can improve the drainage, let the water flow freely, all that good stuff. And additionally, geogrids do very little to actually stabilize the surface of your roadway, so it's going to require significantly more maintenance since that aggregate is loose at the surface and can get pushed around by vehicle passes. That's exactly what the GeoWeb system is preventing with its confinement. So sort of continuing with the theme of unpaved gravel road surface applications, a washed or a clear stone can be used in the GeoWeb system, allowing you to build stable, permanent, low-impact development access roads. Site access roads, both temporary and permanent, are very common applications for the GeoWeb system. As mentioned, heavy vehicle loads can drive on the GeoWeb system immediately after infilling to finish construction, so pretty big time saver. And with the GeoWeb panels and then a woven geotextile underneath, which is what you see here, you can actually bridge wet, soft ground, creating access roads with little to no disturbance. Saturated soils usually can't support really any type of vehicle load, and woven geotextiles can't do it alone. They do add additional strength to the system, and they're not going to get clogged by your subgrade material, so they still allow for water movement to go through freely. And the clear stone infill combined with the perforations in the GeoWeb cell walls allows water to flow both vertically and laterally through the system, limiting impact in your sensitive environmental locations in ways that a paved asphalt or concrete road can't. Apologies for that. So this was a project through the Duke Energy system in Florida to install new transmission towers through wetlands. High winds from Hurricane Michael had demolished over 100 towers in this line, all of which had to be restored over this extremely soft subgrade. So you can see how easily people were sinking in with those deep footprints. Imagine vehicles going through. So the GeoWeb system was used for access and maintenance roads, as well as building up pads around each tower. So the saturated sand really couldn't support any type of vehicle loads on its own. So a combination of woven geotextile and the GeoWeb system was used. So by using that, it allowed for the water to still flow freely through this wetland system, so limited environmental impact. But we were then able to use that sand from the local site. So it was that low quality material that you typically wouldn't get to use with a GeoGrid, but you can use with the GeoWeb system. So it's really nice that it was easily sourced and transported to these really remote locations without needing to bring it from really far away from a batch plant. And so once the panels are filled in, both wheeled and tracked equipment can drive over the GeoWeb system quite easily, even when that infill material is sand and you normally wouldn't be able to. And again, you can see how the GeoWeb panels act as their own access road. Just keep filling up the cells in front of you. You don't need to build temporary roads around it. Just use what you already have. Okay, so now we're going to move on to embankment stabilization using the GeoWeb system. So many times slopes and embankments are needed to be stabilized after or in conjunction with road and highway construction. So the GeoWeb system for slopes can be filled in with a couple different materials depending on your project needs. Topsoil with vegetation is probably the most common, but sometimes vegetation is not appropriate. So you can also use stone or concrete as your infill options. So here's a pretty simplified diagram showing all of the different components and how they interact with the GeoWeb panels to form that complete system. Typically, the first thing to go down, if required, is going to be something like a geotextile. It's not always required to have one. Sometimes it is. Usually it's going to depend on what your native soil is. Then you place the GeoWeb directly on top of that. And notice how the GeoWeb has that sort of horizontal turn at the crest down into an anchor trench. That's going to be really important to help hold it in place. And then as we showed earlier, there's a couple different options for anchoring. You can use stakes if you have that shallow slope, or you can use tendons if you have a really steep slope, or if you've got a geomembrane that you can't puncture, something like that. When using tendons, you have to have crest anchorage. Typically that crest anchorage is going to be a dead man pipe or earth anchors. But if you do have infrastructure right at the crest of your slope, such as a building, a roadway, something like that, you can also anchor to that infrastructure if it can support additional load. That's going to be very project specific, and we can help you determine what's going to be the most appropriate for your site. So the GeoWeb panels work in multiple ways to protect your slope surfaces. It does prevent significant movement of the soil by confining the soil to individual cells. And by separating the soil into those smaller segments, the system resists mobilization of the entire slope face due to hydraulic loads and prevents that soil erosion. So it's important to reiterate that the proper installation of the GeoWeb system includes embedding the GeoWeb panels into the crest of the slope. This prevents water from flowing beneath the GeoWeb panels and undermining the system. You don't want rills or gullies to form underneath the panels where you can't see them, potentially leading to failure. The system provides a way to fully vegetate slope surfaces that otherwise could not support sustainable plant life and increases the overall slope stability by interlocking with the vegetated root zone. Stone or concrete materials can also be confined within the GeoWeb panels, again, on slopes that might normally be too steep to allow for natural vegetation or natural stone slopes alone. Like I said, vegetated slopes are probably the most popular option because they can result in the most attractive slopes, and typically they would have little to no maintenance. Always a positive. So this was a vegetated slope over an unstable soil slope at an active gold mine in Canada. With variable slope lengths and face angles, it required a flexible solution. Plus, an access road was going to be built on top of the slope, where you see the excavator here. So the slope had to be stable enough to support the expected traffic live load. So a couple different things that needed to be considered. So here you can see that there were also space constraints at the top of the slope in the form of that access road, plus potentially an access road at the base of the slope. So you can also install things like fences, rail posts, other small infrastructure directly through the GeoWeb panels. So that's a nice little bit of flexibility and customization that you have with the GeoWeb system that you wouldn't necessarily with other types of systems. Plus, now you have a steep slope that otherwise probably wouldn't have been able to withstand on its own, fully vegetated, and it's going to withstand the test of time and heavy rain events. This was a slope alongside a road in Ohio, which shows a pretty common problem solved with the GeoWeb system. Erosion and washout of soil slopes onto your road surface is going to be a problem in many locations. Covering the slope with the GeoWeb system and then filling it in with topsoil allows for a vegetated slope without the concern of constantly having to replace the soil after storm events. We do recommend some sort of surface protection, such as hydroseeding or using an erosion control blanket, be used over the GeoWeb panels until vegetation has had a chance to grow. So it just gives you a little bit of flexibility until that grass starts coming in. So the embankments along a roadway have to deal with things like sheet flow runoff from your impervious surface, like this slope here, from Maryland State Highway Administration project. The sheet flow off the roadway can cause sloughing of large sections of the upper topsoil layer, causing deep rills or gullies and preventing vegetation from taking hold. The GeoWeb system holds that soil in place while allowing the water to run over the surface. So no more gullies, and now vegetation can form those deep roots to help further stabilize the soil. So sometimes you just have so much rain, the rain events are so common, vegetation just never got a chance to establish itself, even if it normally could have. So with the GeoWeb system, it gives it that little bit of extra strength and protection against that water flow movement to let it grow, let it really get those roots deep down and get you that nice stable slope. Things like road widening is becoming a lot more common with state DOTs trying to find more roadway space without displacing any significant structures. The slopes or embankments are usually where there's additional space to be found, such as this road widening project in New Hampshire. The GeoWeb slope protection system allows for steeper slopes to be created than normal without erosion concerns. The system can be installed quickly and vegetated quickly, so there's not going to be a long construction time that might shut down your important roads. Ease and speed of construction are some important features of the GeoWeb system that everybody appreciates. So this was a project in South along the Zaramilla River between Peru and Ecuador. The river was full of mangroves, and the currents can easily pick up sediments and soil, eroding the banks and threatening infrastructure. Extreme El Nino events cause catastrophic flooding in this region, and climate experts predict more severe storms from the Pacific in coming years. During a brief dry spell, the river banks were cleared and regraded to allow for the installation of the GeoWeb slope protection system. The system also provides excellent resistance to sheet flow, eliminating the formation of rills and gullies, especially in areas of concentrated flow over erosive soils. In many areas of this particular project, protection of the slope surface allowed for the construction of steeper embankments with less horizontal footprint, thereby conserving valuable land space. Contractors were able to install about 2.4 million square feet of the GeoWeb system along the compromised riverbank slope. Installation rates are typically going to be around 1,300 square feet an hour for a crew of 4, including your operator. At the Zaramilla project, the contractor further optimized installation rates by pre-staging sections and assembling the system at the crest before expanding the panels down the slope face. The GeoWeb shoreline protection system filled with concrete was selected to protect the Zaramilla riverbank against future storm events. The GeoWeb system with concrete infill provides your economical hard armor protection of slopes and channels exposed to high flow velocities and high shear stresses. The system has been proven to withstand flow velocities over 36 feet per second, or about 11 meters per second, and shear stresses of around 21 PSF, or about 1 kPa, outperforming things like riprap, gabion baskets, and other conventional hard armor strategies. The quality, surface finish, and thickness of the concrete can be selected to meet your specific design needs. The concrete-filled GeoWeb system comprises of flexible, poured-in-place sections that are more economical than articulated concrete block systems, ACBs, and they don't require specialized equipment to install. The GeoWeb shoreline protection system is quick and easy to install and doesn't require extra training or specialized needs. And the complete system is going to be formless and poured in place, eliminating the need for conventional concrete formwork and rebar reinforcement while ensuring consistent pour depths. The whole project took around 4 months to install, including the excavation work. The system becomes a flexible concrete slab that conforms to minor subgrade movements, prevents uncontrolled cracking, and reduces the potential of piping or undermining through the slope faces. This work can also be integrated into existing infrastructure within the area. The GeoWeb protection system was placed up against bridge abutments and formed around culverts and drainage areas. So you don't need to redesign what's already in place. You can work with the roads and bridges and landscape that you already have to create a solution. And with concrete, it is going to be a permanent solution, even with the more extreme weather events in the region. Plus, the GeoWeb shoreline protection system is going to be performing to expectations and will provide some much needed protection to the Zaramilla River. The communities that depend on it for the next several hundred years really are going to be able to withstand through many major storm events. So definitely a good peace of mind. However, if global stability is going to be a concern, or if you do have steeper than 65-degree banks, so it's going to be pretty steep, slope protection isn't going to be sufficient. You are going to need to have a retaining wall. The GeoWeb panels can be stacked vertically on top of one another to create a gravity retaining wall, and GeoGrid tieback reinforcements can be added if necessary, similar to MSE block or gabion basket walls. The walls can be filled in with topsoil in the front cells to create a living green wall and can be built to support vehicle or building loads. So there are 2 different options with walls when you consider the cross section. One is going to be gravity walls. You're going to have longer pieces of GeoWeb at the bottom, shorter as you go up, sort of become a triangular option. And then the weight of the infill GeoWeb panels provides the retention. Or you can have GeoGrid reinforced walls. The GeoGrids provide retention, and then the GeoWeb panels function as a fascia alternative. So there's going to be some reasons why you would choose one or the other. If you do have specific questions about that, feel free to reach out to us and we can help you decide what's going to be the most appropriate for your project. In either case, the front cell can be filled with topsoil, and then the back cells and reinforced zone can be pretty much any drainable material, including salvaged on-site soils. Retaining walls are a whole process unto themselves. We aren't really going to be able to talk about those details today, but like I said, feel free to reach out. We're more than happy to discuss. So the GeoWeb walls are going to be the preferred solution when you're dealing with poor soils with significant settlement potential. A GeoWeb retaining wall saw a major earthquake event resulting in a sliding of the whole slope area. As you can see, the GeoWeb wall system sustained no damage, but those concrete flumes were broken beyond repair. So think about how a rigid concrete MSE wall would have been damaged in the same way, potentially leading to catastrophic failure and damage to the infrastructure at the top of the wall. And without the concrete MSE wall, by using the GeoWeb wall, you were able to avoid all of that. So this was a Ohio DOT project with a 20-foot high wall that was constructed to keep a rock face from further erosion. The GeoWeb system is the fascia along the wall face that helps protect the road without taking up a lot of horizontal space. So this is a great option if you know you have unstable rock walls or steep soil slopes in seismically prone areas. The GeoWeb wall can support and maintain the wall face during normal times. And after a good ground shake, the GeoWeb wall is still going to be in place and can help prevent rockfall or landslides from compromising your roadway. And the GeoWeb system works great along shorelines of stormwater channels. Placing the panels along a shoreline can help prevent erosion due to water movement or wave action. This project was along a stormwater diversion channel that helps move hurricane waters. So during the hopefully infrequent hurricane season, the channel floods and could be severely eroded on the channel side slopes each time. And there's obviously infrastructure on each side of the channel that you need to keep safe. So it's really important to keep the channel within its banks. And to do that, we use the GeoWeb system. So here's that same wall, but now there's going to be that water flow along the bottom after that hurricane storm event. The GeoWeb walls can withstand some pretty significant flow velocities depending on the infill material that's chosen. Here the client used a mix of stone aggregate and topsoil. The topsoil allowed for vegetation growth we saw in the last picture, so that the GeoWeb material itself is camouflaged and it looks like a regular wall or slope. But the addition of the stone in the mix allows for greater resistance due to erosion from water flow. So it's great that the GeoWeb system offers this kind of flexibility. Plus, above the GeoWeb wall, you can also have just your standard grass slope so that you can minimize the amount of wall building that's required. So build enough to contain your 100-year, your 1,000-year, hopefully no more than that, storm events, and then whatever your location is going to require, and then go back to your regular area projects with no problem. So you don't have to build a massive wall just because you need the height, even if you don't need that much height for your water. So the flexibility of the GeoWeb system gives you a lot of possibilities to play with so that you can have a customizable project for your specific needs. So this was a fun project that really shows the durability of the GeoWeb wall. So this was a small town in northern Iceland that wanted a more permanent avalanche protection wall without it looking too unnatural. So the vegetated GeoWeb wall came in. So this wall was built from the ground up, completely freestanding, rather than integrating into an existing wall or slope. So this is something that you definitely can do with the GeoWeb system, create these new freestanding walls. You can build them also as dikes or water containment panels, that sort of thing. So if you want to create a new channel from a flat area, you can build up these freestanding GeoWeb walls. So the wall had to be built so that it would protect the majority of this Icelandic town from the most anticipated avalanche direction. So the GeoWeb wall curved and moved with the landscape. And the internal strength of the GeoWeb wall is enough to withstand that first huge impact of snow. And the structure had to be high enough to allow for significant buildup of snow during an avalanche event. Plus, access roads were built around and on top of the geoweb wall to make sure that the structure stayed clear of obstacles and could be cleaned up after an event. And finally, you can start seeing it grow some grass here. It's going to get green, look a little more natural. Eventually, all that black plastic is going to be hidden from view. And now the town has a permanent solution for protection of their own extreme weather challenge. So obviously not everybody is going to be in avalanche zones, but there are definitely communities that are, and this is an interesting sort of solution that you could choose. And then our last topic for today using the GeoWeb system is going to be for stormwater control for mitigating flooding after storm events, even heavy storm events such as hurricanes. So the GeoWeb channel protection system is going to be really similar to the slope protection system, just covering either entire channels or just single embankments. You can have continuous or intermediate flow, low to high flow, and a variety of channel dimensions. So again, you have a lot of that flexibility with the GeoWeb system. And the system is going to be much more economical than solutions that utilize large riprap stones or heavy gabion baskets. And several different infill material options are going to be available to meet any channel flow needs. We did have some extensive research performed at Colorado State University to show how the vegetated GeoWeb system can perform in channel conditions compared to heavy riprap stone. What we determined was that when paired with a turf reinforcement mat, a TRM, the GeoWeb and TRM system can resist extremely high flows, allowing for velocities up to 30 feet per second and really high shear stresses. So this is pretty significant compared to just the typical unreinforced vegetated channel. So it allows you a lot more flexibility without needing to go into a hard armor solution if you don't want to. So the GeoWeb system works great along shorelines of stormwater channels. Placing the panels along a shoreline will help against erosion due to that water movement and wave action. So you can see how it was placed on these stormwater channels and how you can use it to help keep the channel within its banks even during heavy storm events. So the GeoWeb panels are placed both above and below the average water line for this type of project. The panels do need to go below the water line to ensure that they don't get lifted up due to wave action. And you then can protect the entire shoreline all the way to the stable channel bed. The area does not need to be de-watered for this type of installation. You can actually install it while wet. And the GeoWeb panels are going to initially float, but then you're going to anchor them down in place, typically with stakes along the slope face to help hold it in place. And then once the infill material is put in, that system is not going anywhere. Then here you can see the final surface after the vegetation has been fully established. You don't even know the GeoWeb panels are there. It looks really natural. The performance of the GeoWeb allows it to handle fluctuations in water depth and the associated velocities and shear stresses, while still preventing erosion on the side slopes. Using a soil and a grass type that's going to be local to your area, maybe even using salvaged materials from the excavation process, is going to help with blending the system in so that the GeoWeb panels aren't noticeable. But now you can walk along that shoreline without fear of sinking in, and the shoreline is protected against erosion for years to come. Channels can also be filled in with aggregate or concrete. Stone infill might be appropriate if you are in an arid environment or otherwise don't believe that vegetation is going to grow in your area. It's also important to keep in mind that vegetation can't grow in water usually. So if your channel has a consistent water depth, stone infill may be required underneath that mean water level. And concrete infill is going to be the go-to choice when you know that you're going to have extremely high flows. So there are no restrictions in terms of flow or shear stresses when concrete infill is used. So if you are on a really steep slope, or if you're working on your 10,000-year storm event, concrete might be the best option. You can even include things such as baffles or energy dissipators to the GeoWeb channels with no issues, no detrimental effect to the GeoWeb system to try and help slow those high velocities if you're going into something like a stilling basin. So this stormwater channel project was in Florida and shows how the GeoWeb retaining wall system can be used in those water flow environments as well. The stacked system can be used in those urban areas where there's no room to lay back the side slopes, and that way you can have more volume in the same footprint. So great for along roadways and highways. In this case, vegetation was used above the mean water line for a natural look, and then concrete was used below the water line to help resist scour and erosion due to that constant water flow. So you are able to have flexibility in your infill materials as well. You can use concrete on the bottom, so that way you're not going to have any erosion or scour, and then you can use vegetation above the water line to give you a little bit more natural look. So again, what you need for your site, we can usually help with. We can give you that flexibility. And the GeoWeb system can also be used in conjunction with things like riprap if there's potential for very high flows, but you're still hoping to use vegetation. So this was a culvert outfall in Milwaukee, Wisconsin. Stronger surface protection over the panels, such as a core fabric, can also be used to help withstand high flow events. And this was intended for short duration events rather than continuous flow. So again, this is just showing that there's lots of different options. So whatever your project needs are, we really do urge you to come to us, talk it out, see what we can offer. There's no one right solution. There are lots and lots of potential solutions, and usually we can find something that's going to work for your specific needs. And the flexible GeoWeb panels can also easily accommodate things like culvert pipes or other obstacles so that there's no gaps in your protection, including things like sonotubes. Also allows for the addition of guardrail posts, pretty common. So we hear from contractors how easy it is to install the GeoWeb system, even if they've never worked with it before, and how it goes in much faster and easier than things like K-beam baskets or H-pile walls. We do have written installation guides and tutorial videos on our website, as well as providing that on-site or personalized virtual assistance when required. So we're going to work with you to make sure you and your contractors feel comfortable using this type of system. So in summary, every project is different, but the GeoWeb system has a solution that's going to be right for you. The GeoWeb system can be added to road projects to provide a more stable and longer lasting surface course for unpaved layers. It's going to reduce maintenance and repairs. For paved surface, it can decrease the pressures on your subgrades. Plus, on slopes and slopes and channels, you can provide against that erosion concern, or you can even build up retaining walls, both for freestanding walls or for in stormwater channels where there's going to be water flow. So there's a lot of flexibility. We can meet your project needs, and it is a complete system solution for ease of installation and peace of mind. So part of our complete solution is going to be our technical assistance. This is where I come in, the engineering team here at Presto. So we work closely with landscape designers, engineers, contractors, offering a free project evaluation service for any type of road, embankment, erosion control, any type of project really. And so this is a form that's on our website. It's prestogeo.com. You fill it out with as much information as you have, including attaching documents such as geotechnical reports, project site pictures, other info. It comes directly to myself and the rest of the engineering team. Then in 3 business days, but honestly usually a lot faster than that, our in-house design engineering team is going to provide a complete design evaluation, including infill recommendations and anchorage requirements. So we're going to work with you to get the best design for your project. And we do deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications so you can deliver certainty and build with materials you can trust. No disclaimers, no concerning fine print. And that's my presentation for today. Thank you so much for attending. Please feel free to visit our website, prestogeo.com. We have lots and lots of information on there. We have case studies, we have site photos, that sort of thing. Also, you can send us questions at any time. A little bit of housekeeping, you have earned a PDH credit for listening to me talk today. So if you are watching live, you can expect an email from GoToWebinar within about 2 hours with information on how to download your certificate. So it's not coming from Presto Geosystems, it's coming from GoToWebinar. Check your spam folder if you don't see it, but you should see it within about 2 hours. You can also go to our webinar dashboard, which is available to easily view our library of webinars and download PDH certificates for on-demand webinars completed. So your webinar dashboard will keep a record of the on-demand. So this webinar and many others have been recorded. You can watch them or rewatch them at any time. and you will earn a PDH credit for all that you've watched. So keep an eye out. In 2 to 3 days, you will receive an email from Presto Geosystems with information about accessing the webinar dashboard. So one email from GoToWebinar for your PDH, one email from Presto Geosystems about the webinar dashboard. So keep that in mind, but feel free to call me or go through our website if you do have any questions. There are some good questions that came in, so I'm going to go through those right now. The Q&A session is also going to be recorded and available on the webinar dashboard. So if you do need to log off now, thank you so much for attending. Feel free to come back later and listen to the Q&A session, see if you can learn any more. Otherwise, let's get started with some of these questions. Okay, so what is the freezing and thawing impact of the GeoWeb system? So how does it handle freeze thaw? So the GeoWeb system has been and can be installed in cold weather environments. Talked about some up in Canada. We've done some in Northern Europe, in Russia, in very far south in South America, where they get some really cold environments. So it is definitely possible. And with freeze thaw, you actually have a lot of flexibility with the GeoWeb system. Because the system is so open, it actually allows for the freer movement of water to freeze, thaw, expand, contract, without necessarily having a detrimental impact to your roadway surface. So you're not going to have that heave due to frost, because the water can move in the system, move within the void spaces of those stones without lifting the whole thing up. So if you do know that you are concerned about that, perhaps you know you're going to have a lot of frost heave in your subgrade soils, definitely something to talk to us about. We've had a lot of experience with it and we can help out, but it shouldn't be something that stops you from using this system. It definitely is possible to handle pretty heavy freeze thaw cycles. Some questions about what type of vegetation to use for both steep slopes and in channels. And really the best thing that we can say is that use something that's local to you. Don't necessarily go for Kentucky bluegrass if you're living in, Germany. That's just not going to look right. It's not going to be something that's native. It's not going to look like it blends in with the surroundings. So your first and best option is go with something local. And really what you want is a nice hardy grass or flowering vegetation, something that has a really thick root zone, because that's what's going to help provide some of that resistance to your water flow. There is no one right type of vegetation. If you do have questions, say, hey, can I use this? Honestly, I'm not an arborist, so I'm probably going to say yes, but it's really not something that is going to be your biggest concern, what type of vegetation. Go with something local, go with something that would grow there naturally. Looks like some questions about using the GeoWeb walls in those stormwater channels. What the infill material is, how to prevent that scour, that sort of thing. So you can use topsoil or really any type of soil to grow vegetation. Stone and concrete are going to be your main infill options. You can mix and match those. They don't have to be a single type in the entire wall. So you can have vegetation in some of the cells and then things like stone or concrete in the bottom. And so that's going to be good if you know that you're going to have those water flows, that constant water in your channel that might prevent that vegetation growth. Put in stone at the bottom. That's going to help prevent scour. It's going to help, not have to be constantly trying to replace and grow grass underwater, that sort of thing. And you're not going to have any detrimental effect to the performance of the GeoWeb system by having different infill materials. It's going to work really well. It's not going to have any concerns about differential settlement because of that sort of thing. We're more than happy to talk about that with you. Again, retaining walls are a bit of a beast to design. We have a lot of experience with it. We're more than happy to talk about it. But yeah, you're not limited to a single type of infill material, and you don't have to worry about things like scour or erosion due to water forces. Some questions about durability of the system. So the GeoWeb system is made of that virgin, high quality, high density polyethylene, HDPE. So we chose HDPE for a number of reasons, but one of the main reasons is its environmental durability. HDPE is chemically inert and non-reactive. So it's not going to have negative reactions to environmental conditions, even potentially acidic environmental conditions if you're in potentially acidic soil or in saline environments on a coastline. If you're doing a retention pond off a chemical spill sort of thing, none of that's going to have a detrimental impact to the GeoWeb system. It's not going to break down. It's not going to start cracking. It's not going to lose microplastics. You're not going to have like that particle loss of the GeoWeb system where you're going to be leaching plastics or chemicals into the environment. None of that is a concern with HDPE. It is a very stable plastic system that is not going to have a negative environmental impact. That's part of why we say that it's going to have that really long-term durability. We've lab tested of over 150 years, even under really harsh environmental conditions. So you can put it in the ground and basically place it and forget it. You don't need to come back later and see what kind of harm it's done to your environment, because there isn't any. So we really pride ourselves on that sort of durability and the eco-friendliness of building up your soil systems with the GeoWeb system. Let's see, I'll do one last question today. So about the GeoWeb for roadways. So does the panel, it's a two-part question, does the panel need to be fully expanded to be able to function? And does it need to be visible at the surface, or can it be buried? So two good questions. We do have some installation guides on our website. I want to highlight that as something that could potentially help with some of these questions. But in terms of, does it need to be fully expanded? We do recommend it. It is probably beneficial that it's fully expanded, but if you don't necessarily need to cover that full area, you can have it be slightly under expanded as long as it's still fully filled in with your infill material, your sand, your aggregate, your concrete, that sort of thing. The idea is that you still want to be able to fill it in with your material and have that material be fully confined. So that's going to be the key point. And then in terms of, does it need to be visible at the surface or can it be buried? And the answer is it can be both. So you can be visible at the surface right at the top. You can drive directly on it. You're not going to cause damage to it if it is visible, or it can be buried. You don't want to bury it too much though, because the deeper underneath the surface it is, the more unconfined material that you have above the GeoWeb panels is going to be more material that isn't being influenced by the GeoWeb system. And so you're going right back to the problem that you're trying to solve. Unconfined materials on roadways is going to be cause for rutting. It's going to have constant maintenance needs. All of that stuff going to be wind and erosion forces are going to have effects. So you can bury the GeoWeb, but you don't want to go too deep because you're losing the benefits of using it. If you do have specific questions of how deep you want to bury it, please reach out. We're more than happy to discuss that. And I'll say that for really any sort of concern that you may have about this type of system, if you haven't used it before and you're like, well, I don't know if it can do X, reach out. We're more than happy to discuss. We've done some pretty unique installation cases. I'm not going to say we've seen everything, but we've seen a lot. So we're more than happy to discuss these sorts of things with you. So look out for those emails about your PDH certificate and about the webinar dashboard. Thank you so much for attending today. I really hope you learned something and I didn't bore you too much. And I hope to see you in our next webinar. Thank you so much. Bye.